Hello everyone, welcome back to my mathematics channel. Today I would like to teach you on congruency, enlargement and combined transformation. For your information, this is actually Form 5 syllabus. So we have a very special terms which is congruency, and then we will learn enlargement. We also will learn combined transformation. Alright, so today we will start with chapter 5. What will you learn for this topic? So basically you will learn congruency, right? And also you will learn enlargement and combined transformation, which is actually I think quite interesting, right, for this topic. So let's focus to the term first, and then the last one is actually tessellation, which is totally new to a mathematics syllabus compared to old syllabus. So we have congruency and tessellation, which are actually very special topic that is a totally new syllabus. Enlargement and combined transformation is actually still the same with the KSSM. Okay, so looks like we are going to start with this chapter. So let's study the chapter first. Now, for this chapter, why study this chapter? So astronomers use a telescope to observe the surface of a planet. The surface of the distant planet appears to be magnified through the telescope. Magnify. Alright. However, the resulting is inverted with its original objects. Refraction is applied to get the actual picture. Refraction, alright? So actually this one is actually the introduction. So it actually mentioned about the enlargement and refraction is very important. Okay, do you know Johannes Kepler was a German mathematician? Johannes Kepler, right? Okay, so let's highlight the keywords. Was a German mathematician and astronomer who had documented the study of tessellations in 1619. He used the concept of tessellation to explore and explain the structure of snowflakes. So let's have a look at the snowflakes, which looks very interesting. It is very beautiful, right? So as you can see, we have this one. We have different. We have this one. The shape is so special, right? So this is a snowflakes, all right? So it comes with a very systematic lines and then angles and the patterns. Looks very in order and systematics. All right. Now let's continue. Alright, so let's revise the word bank. For this topic, the important keywords, alright? Scale factor, congruency, similarity, refraction, enlargement, rotation, tessellation, transformation, and finally translation. So all these are important keywords for this topic. let's go through this topic. Introduction. Alright, let's have a look of this Trangano Bridge. It looks like very artistic. Wow, it's so high and so beautiful, right? Alright, so this is actually the Trangano Drawbridge, which is actually located in Kuala Trangano. Is a new landmark for Trangano in 2019. It is the longest drawbridge in the world with a length of 638, the longest drawbridge in the world. 638 meters connecting Kuala Trangano and Kuala Nerus, the river mouth of Sungai Trangano. The unique features of the bridge is that it can be lifted in the center to facilitate the passage of large ships beneath it. Observe the structure of the bridge, which parts have congruent shapes. Let's observe. You can see the congruent design here, right? This one looks like congruent. The pattern is congruent, right? Okay, so you can see the shape here is a congruence pattern. Alright, so this is actually very special building, right? So you can see the design, which is so beautiful. Alright, okay, so this is the bridge. Now let's see. So today's learning standard is to differentiate between the congruent and non-congruent shapes based on size and angles. Congruency. How to differentiate between the congruent and non-congruent shapes. Observe each of the diagram below. What is your observation regarding the size and shape of each pair of objects drawn? So let's have a look. The tiles, two pieces of tiles, are they congruent? Petronas Twin Towers and the front and rear tire of a car, right? Rear tire of the car. Okay. The pairs of objects in the diagram above have the same size and shape regardless of their position and arrangement. So the pairs of objects are congruent. So they are congruent. So let's continue. So my mobilization. So you have to do in pairs, right? To explore the congruent shapes based on size and angle. Okay, so you can scan the QR code and then you can do these activities. Okay, for your information, actually you can refer to one of the video that I created. So actually you can have a look, and this activity is actually talk about congruent shapes based on size and angles. So then we proceed. So the result of my mobilization 1 shows two congruent polygons have the same measurements for the corresponding size and angles, like this. Okay, in the diagram above, quadrilateral ABCD and PQRS are congruent with the condition shown. So length of the corresponding side, so that means the length for each of the corresponding side, the AB, okay, AB, and then the RQ. So I'm using blue color to show they are equal. So, and then BC, I'm going to use another color. BC, I'm going to use green color. So the BC and the QP, these two are the same length, right? And then we have CD. We can choose another pair, which is CD. Okay, I'm going to change the color to purple. CD. Oh, so let me change the color. CD is here. This CD is the same with the PS. So normally we use 3 lines to show their equal length. The third line, and the second one we use 2 label, and the first one we use just 1, right? That is how we show their equal length. And actually for the angle we will use the BAD. This angle, the blue one, is equal to QRS. These two the same, right? The one in blue. And then ABC, I'm going to use the green one, ABC. So this one, ABC, is actually the same with the RQP, right? These two the same. And then finally we have BCD. BCD, I use a purple color. The BCD is actually the same with, this is BCD, is the same with the QPS, this one. Okay, purple and purple, green and green, blue and blue. So these two triangles is so-called congruent, right? So that is definition about the congruent. They are actually same in terms of length and the angle. Okay, for every corresponding sides and corresponding angle must be the same, right? So I'm going to explain to you for this example for the congruency later. So if any corresponding side or angle of the first shape is not equal to the second, both shapes are not congruent. Okay, any corresponding side or angle not equal, either the angle or the side not equal, they are not congruent, right? Okay, so we have understand what it means by congruency. So let's see, the triangle ABC and PQR, which are congruent, can be written as this way. So if they are congruent, this is how you actually use a symbol for the congruent, like this, right? This one means congruence symbol. Alright, so I have introduced to you congruency. So we'll discuss further on exercise in the next lesson. Alright, now before that, let me continue with this one. The learning standard is make and verify the conjecture of the triangle congruency based on the sides and angles. So two congruent triangle have equal corresponding sides and angles. Okay, can we say that two triangles are congruent if we compare only one part of the corresponding angles and sides? Right. So my mobilization, so you can have a look of the one of the video that I created, so you can try the activity and then make a conclusion based on the sides of the and the angles. So the results of the mind mobilization is that congruent triangle have the following properties. So either we call as side, That means all the length of corresponding sides are equal, like this. So this is side, 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 which is we call as S, S, S. Alright, all the sides are the same. Okay, then we have also SAS. For SAS, we have actually the two corresponding sides. Two corresponding sides are equal, okay, in length. And the size of the corresponding subtended angle between the two sides are equal. This is called SAS, meaning that, okay, we have two sides here and this angle. Subtended, this is so-called subtended. Okay, subtended angle. Subtended angle, right? Subtended by the two sides. So this is so-called SAS. And beside this, we also have the ASA. Two corresponding angles are equal, and the length of the corresponding side between the two angles are equal. Meaning that we have two angles. We have two angles and one side. Angle, angle, side. Angle. Okay, we have angle, angle. Between the angle, we have the side. Okay, so angle here, side here, angle here. So just now we have side here, angle here, side here. So side, angle, side, SAS. So we also have ASA. And we also have the angle, angle, side. Two corresponding angles are equal. Okay, and the length of one of the corresponding sides which does not lie between the two angles are equal. Okay, does not lie. So we have, okay, we have angle, angle, and this side is not between the two angles, right? Angle, angle, side. So it's different with the angle, side angle, whereby the side is between the two angle, and this one, the side is not between the two angle, right? So we call it AAS. How about AAA? Angle, 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 meaning that all the three corresponding angles are equal. Then the area of the triangle must be equal. There is extra condition. Area must be equal, right? So that means even though the angle, all the three angles are the same, the area must be the same, must be equal. Then they are congruent, right? So remember, this is an extra condition. Area of the pairs of triangle must be equal. Side, side angle. How about side, side angle? For side, side angle, we have two corresponding sides equal in length, and one of the corresponding angle which is not subtended between the two sides are equal. So we have the two sides, and then this angle is not between the two sides. So we call as side, side angle. So altogether we have how many scenario? We have number 1, which is side, side, side. And then we have number 2, which is side, angle, side. And then number 3, we have angle, side, angle. And number 4, we have angle, angle, side. And number 5, we have the all the three angle. And finally, we have the side, side angle, right? Okay, so for the side, side angle, the condition applied is the area of the pairs must be equal, right? Same like just now, angle, 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 and side, side angle. These two, there is an extra condition. Area of the pairs of the triangles must be equal, then only they are congruent. So we have 6 situations, right? Alright, so we'll discuss more in the next video. Before that, let's have a look of this one. Side angle and angle. This one you have to pay attention. Side angle and angle can be used to determine two triangles are congruent except the area, the condition, the extra condition. Area of triangle are the same. Okay, the keyword is area must be the same. Alright, so we'll continue in the next video sharing to discuss more on congruence of the triangles. Till then, bye bye and have a nice day.